So here we are, lesson 16C. In the next preview assignment and in the next class, you will need to create column graphs. Wow, column graphs. Oh, brother. Those things, column graphs using a spreadsheet and calculate relative frequencies from a table of data. Relative frequency. So during an in-class activity, we have gathered data about the number of hours we spend working on math homework outside of class. And in this other in-class activity, 16C, we are going to be investigating our entire class's data. Suppose that 30 students in a different class at your school recorded the number of hours each student worked preparing for a class in a typical 7-day week. The data are recorded in the table I'm going to put up next. This table is sorted by the number of hours each student studied in a typical 7-day week. If you haven't already answered questions 1, 2, and 3, and even go on to 4 and 5, but at least 1, 2, and 3, pause the video, do those questions, and then come back and let's walk through them together. Question 1 says, use the class data from this table to determine the number of students in each range. So I'm looking at question 1, there is a table, and then I'm looking at the current table that you see here. On question 1, it wants to talk about the amount of time spent studying, and the first thing it says is to look at no hours spent studying. And the number of people here, 1 student. Then it says how many from 1 to 5 hours. And if we block from 1 to 5, we'll find that after you count them, I've already counted them, there are 12. And then it wants to know from 6 to 10 hours. We don't have anything representing 6, but we can catch 7 to 10. I've already counted these 2. There are 9 of them. And then that leaves us with the bottom part of our chart, and it's asking on question 1 for us to look at more than 10 hours. So not 10, more than 10. And the amount of students here are 8. I need you to keep going on to question 2, because then question 2 says, let's look at a relative frequency of a category of data in the sample, and it is the percentage of the sample data represented. Using the data we got on question 1, we're going to calculate the relative frequency of each range and fill out this table. So realize the first thing that we looked at is a frequency. How often are these numbers mentioned? Now to do a relative frequency, it's going to be a percentage, relative frequency. That is a Y. A relative frequency means that we have 30 pieces of data listed in this chart. So beginning with this first one, 1 out of those 30, when I divide and it says round to the nearest hundredth, we get 3 3/3300%. So make sure your eyes or your brain are noticing that we have frequency and then relative frequency, how they're alike and how they're different. So now moving on to 12. My frequency of 12 out of the 30 students will put us at 40. And if you want to be official here, let's do 40.00 to round to the nearest hundredth %. Continuing on, this is 9 out of the 30. When I divide and multiply by 100, I get 30 or 30.00, and 30 is fine. And then on the last one, 8 out of my 30 gets us at 26 67/100%. Question 3 then says, how would you use the percentages in the table from question 2 to calculate the number of students in each of the category? Whoa, if you only knew that there were 30 students total. So now they're saying, hey, let's go backwards. So if we know that in our first category it represents 33%, and we know that we have 30 students, we can punch in our calculator 0.0333 times 30, and on my calculator it's 0.999, which is essentially 1. So question 3 says, how would you do this? We would multiply each percentage, like the 40%, times our 30. So let's do it one more time. 0.4 times 30, and it comes out exactly 12. So we would multiply those together, or multiply the percentage times the 30, and we would end up being able to go backwards and come up with our frequencies. So finally then in this lesson, and again, if you haven't already completed questions 4 and 5, pause, go work on them and then come back. But looking at question 4, the categories and relative frequencies you just computed in question 2 can be represented in a stacked column graph. They want us to use the following outline instead of axes to create a stacked column of our data. So the data that we had, and it's the sample class distribution, down here at the bottom, and I'll even try to use different colors. Down here at the bottom, and we'll make a key as we go along, this was our 3 3/3300%, and this is the one that represented students studying 0 hours. Then we had, where are my numbers? We had 40% for the 1 to 5 hours. So the 1 to 5 hours, 40%, 1 to 5 hours of studying. So now I have 3 already there. I'm going to add 40, so that's going to put me at about 43. The next part would be students who studied 6 to 10 hours, and that was 30%. So if I'm here at 43 and I'm going to go 30, that'll be 53, 63. So I'm sitting up here at about 73%. And then finally, we are looking at the 26.67, which is about 27%, who were more than 10 hours. And if we're sitting at 73%, then that leaves us with our 27%. So in this question, they are asking us to create this stacked column graph of the data. Question 5 then says, and we could write over here on the side percentages, just like they did earlier, but we're going to move on. And we're going to look at question 5, and it says, why was it helpful to have the table of hour amounts sorted from smallest to largest in the first table of example class data values? And one comment could be that since the list was sorted by hours, the number of hours in each category could easily be calculated by counting consecutive data values. It made it a lot easier and more efficient for us. So that now concludes lesson 16C. You know the drill. Check your syllabus. If you've got more to do, do it. If you don't, happy dance and move on. I'll see you soon.